Solving by elimination. We're going to look at a problem where we want to solve this system of equations using the method of solving by elimination. Now the way we solve by elimination is we literally want to eliminate either our x variable or the y variable. And we're going to do that by making sure that either our x's are the same number, with one being positive and one being negative, or the y's are the same number, with one being positive and the other being negative, so that when we add our variables, they will cancel each other out. In this first problem, the first equation is 2x minus 3y equals negative 8. The second equation is 4x plus 5y equals 28. Now, when we are solving by elimination, you have a choice. You can choose to eliminate your x's, or you can choose to eliminate your y's. It doesn't matter which one you choose to focus on, but just pick one. Let's start with the x's. Here I've got 2x and I have a 4x. I want to turn them into the same number. So looking at those, I have a 2 and a 4, and I know that I can turn a 2 into a 4. So, because we want one of them to be positive and one of them to be negative, both of these right now are positive. So I'm going to multiply the top equation by negative 2. This way, I will get a negative 4 on top. However, whatever you multiply by, you must multiply all terms by that number. Otherwise, we just change the problem. So that means I'm going to multiply all of these terms, even on the other side of the equal sign, which many forget to do. Everything is getting multiplied by negative 2. Now the bottom equation, the second equation, we don't need to do anything with that. So I always like to draw a little line here and rewrite my equations. The top equation, after multiplying every term by negative 2, becomes negative 4x plus 6y equals 16. The second equation, I'm just going to write again underneath it. We didn't change that one, so that will stay the same. Now what we want to do is add these two equations together. Notice what just happened. I have negative 4x plus 4x. That's 0. Those canceled out. Hence, we just eliminated a variable. Now I go over to my y's. 6 plus 5 is 11, so I have 11 y's. And then I have 16 plus 28, and that gives us 44. The next step is to solve for y, so I'm going to divide both sides by the number that's in front of the y. In that case, it's 11. And 44 divided by 11 is 4. Now we're not done. To solve a system, we actually need the x and the y because we're actually solving for a point. This is the point that these two lines will intersect at. So I need to find the x value. Go back to your original equations. Pick one. Again, it doesn't matter which equation you choose. I'll pick the first one. And I want to solve for x. So I come over here and I have 2x minus 3y, but in this case we found y to be 4. So I'm going to substitute that in. Equals negative 8. Just writing the original equation. And then we solve. So I have 2x minus 12 equals negative 8. Now to solve for x, I'm going to add 12 to both sides. So I get 2x equals 4. And last step is to divide both sides by 2. And x equals 2. So now we have solved. And it's actually a point. If you want, you could write the solution as a point, which would be the point 2, 4. Now, I was saying in the beginning that you can choose to eliminate your x's or you can choose to eliminate your y's. And it doesn't matter which one you choose to focus on. So just to kind of show what I mean by that is let's go back to the original problem, which we've written down again. So we have 2x minus 3y equals negative 8 and 4x plus 5y equals 28. Now this time, let's eliminate the y's. Now looking at these, I have a negative 3y and I have a positive 5y. Now I can't turn the 3 into a 5, and I really can't turn the 5 into a 3. So we're actually going to have to turn both of these numbers into the same number. Now one is negative and one is positive, so we're good with that. So what is the smallest number that that 3 and 5 both go into? Well, that would be 15. So we want to turn those both into a 15. So what do I need to multiply the 3 by then? The negative 3. I need to multiply that by 5 in order to get that to be a 15. So again, I'm going to multiply every term in this equation then by 5. Now with the second equation, I want to turn that 5 in front of the y into a 15. That means I would have to multiply that by 3, which means I have to multiply every term in that equation by 3. Now I always write it down all 3 times. That way we don't forget one term. Now we're all set. So let's go ahead and multiply the top equation out. Well, that's going to give us 10x minus 15y equals negative 40. Multiply out the second equation. Those were all getting multiplied by 3. So I'm going to have 12x plus 15y equals 84. Next, we're going to go ahead and do the math. So we eliminated the y's, which was the goal. Therefore, we now just have to add our x's together. So in this case, we have 10x plus 12x. Let's draw our line here. And we get 22x. Again, the y's are eliminated. Negative 15y plus 15y gives us 0. Then on the other side of the equal sign, we have negative 40 plus 84, and that gives us 44. The last step is to divide by what's in front of the x. So that means I'm going to divide both sides by 22. Well, 44 divided by 22 is 2. And that is what we got in the first part. But let's go ahead and solve for y. Again, pick one of the 2 equations. Now previously, we chose the first equation. So let's go ahead and pick the second equation. The second equation was 4x, and in this case we already discovered that x is 2, plus 5y equals 28. And let's solve. So we get 8 plus 5y equals 28. Now we want to bring over the 8, which means we're going to subtract, and that would give us 20 on the right-hand side. Divide both sides by 5, and y equals 4. So our solution is the point 2, 4, which is exactly what we got the first time around. So as you can see, it doesn't matter which variable you want to eliminate. You will get the same answer either way.